All right, hello again. This is Jeff Scott talking to you about the Microsoft Security Development Lifecycle, or SDL, field content. We're on about the 9th of our 14 lectures, and this one is on banned APIs. An API, of course, is an application program interface. This is a level 200. So again, what that means is this is an intermediate level presentation. So, we'll give an overview of the banned APIs. We'll talk about the methods for detecting banned functions. Talk about an overview of some of the safer alternatives. You've seen this time and time again, so I'm just kind of whipping through that. And I'm jumping right into the Microsoft SDL banned APIs overview. You know, when you develop apps, Microsoft has found that certain functions within the C runtime library, if they're used incorrectly, can lead to serious vulnerabilities in code. For instance, the STRCPY, which is string copy, and STRCAT, which is string concat, when called incorrectly, can lead to buffer overflows. So the banned Microsoft SDL banned APIs is a documented list of these kind of functions. These functions are prohibited for use in new apps being developed by Microsoft. And the idea is, over time, banned functions that are in legacy applications, so they're already in code, they'll be removed. Removing the use of banned functions is an effective way of reducing the risk of application attacks by malicious users, and it really doesn't take a lot of effort. All right. Preventing it earlier in the process rather than later can save significant engineering efforts, time, and money, as we've talked about in previous lectures. The Microsoft SDL banned API list focuses almost exclusively on preventing the use of functions that can lead to buffer overflows. All right, but as time goes on, Microsoft has promised that they will look at this and see if there's any other functions, any other APIs that should be banned as well. So here's some examples of banned copy functions, banned concatenation functions, banned OEM conversion functions, and banned string length functions. As you can see in here, first of all, this is just a sample of the current functions, okay? There's more than 100 different functions that are listed as banned. And if you want, you can go to the Microsoft SDL book, or you can go online and click the link right here, and it'll take you to the functions in question. So again, this is probably what, 1, 2, 3, 4, 5, maybe a quarter of them right here. Shown on the slide here are examples of taken from previous Microsoft security bulletins and patches that helped establish the need for banning certain functions. Each of these bulletins requires, an extensive engineering process to fix the affected code, produce a patch, test the patch, have people deploy the patch, etc. Deployment strategies have to be planned, executed, and verified. Documentation may have to be updated, etc. And again, as mentioned previously, all of these things lead to a significant increase in effort and costs. Since Microsoft has prohibited the use of these banned functions, they've experienced significantly less reported vulnerabilities in their products. Now again, this isn't for the only reason, but this is one of the reasons why that's the case. Notice here the N functions are also banned. So instead of STRCAT for string cat, there is an STRNCAT for string cat, where you talk about the number of bytes you want to copy over. Instead of STRCPY, there is STRNCPY for a string copy with, again, the number of bytes. So what happened was developers started to use these and consider them to be a safe alternative to the banned functions. But Microsoft has found that these N functions, as they're known, themselves are difficult to use and just as likely to be misused. So they've been banned as well. In particular, the N functions, they don't null terminate overflowed buffers. This can become extremely problematic because other functions that read these unterminated buffers have no way of knowing where the buffer logically ends. So this can result, as always, in buffer overflow errors. Here's an example of why N functions can be problematic. You may or may not, take a look at the code that's in here and see some kind of a potential problem with the code. All right, the problem is that during the strn copy of PSZ SRC into the SZ dest buffer, if PSZ CRC is greater than or equal to 50 bytes, the null termination won't take place. Since the destination buffer is not null terminated, it can cause, at best, unexpected application behavior, and at worst, a buffer overflow condition later in the code. So the N functions can be an effective alternative if they're used correctly. If organizations continue to use these N functions, extra care is required by developers to ensure that the size of the destination buffer has been correctly calculated. All right. Microsoft, though, has chosen to take a more defensive approach, and they've just decided to ban these N functions for use in new applications. In lieu of these banned N functions, Microsoft recommends using STRSafe and SafeCRT as safer alternatives, and we'll talk about those a little bit later on in this presentation. All right, detecting instances of banned APIs. Prohibiting the use of banned functions in apps can greatly reduce the overall exposure to attack. These banned functions can be detected in several ways. For developers using Visual Studio 2005 and above, the compiler will automatically emit warning messages or whenever it detects a banned function instance at compile time. All C4 996 compiler warnings should be investigated to ensure that the function being flagged is not banned for use. You should be wary of any time you get one of these 4996 warnings. Another method that can be useful to detect the use of banned functions is to use the ban.h header file that's included in the Microsoft SDL Book Companion CD. And I believe you can get that online too, if you go out to here. Since C and C++ are implemented on a wide variety of platforms, this header file can be used for applications built on non-Microsoft platforms as well. Finally, the final method is to conduct the security code review. In addition to looking for common coding patterns that lead to vulnerabilities, the verification teams can also search for instances of banned functions in code and for any pragma declarations that disable banned function warnings. All right, so what are the alternatives? Well, some have already been mentioned to you, the STRSafe library and the SafeCRT library, okay? Though it's not, excuse me, though it's not required by the Microsoft SDL, if you're developing an app in C++, the std::string template class can also be used to provide a safer replacement. And they mentioned on the bottom here, they said it's important to note that while replacing banned functions with safer alternatives can certainly improve the quality of code and reduce the exposure for attack, it still does not guarantee or warrant that applications are free from vulnerabilities. Again, there is no silver bullet. We've talked about that before. So let's talk about a couple of these safer alternatives. The first, as mentioned earlier, is the STRSafe library. It provides additional processing to reduce exposure to buffer overflow attacks for both C and C++ applications. The library has several advantages. First, functions in this library guarantee that all string operations will be null terminated. Next, all functions in this library return a status code that indicates the success or failure of a function call. These codes can be useful to developers to help them determine whether or not there was an application error, like a buffer overflow that's occurred. Finally, each function in the STRSafe library requires a destination buffer size parameter. These parameters help ensure that the function is not right past the end of the buffer, which again would cause a buffer overflow. As far as the STRSafe and how it can be applied to existing code to make it more resilient, you might say, to buffer overflow attacks, here's some example code that reads two character pointer parameters, S1 and S2. A buffer of 32 bytes has been allocated on the stack. S1 is copied into the buffer. S2 is then concatenated into this buffer. And there's a problem here. There's two real key security concerns here. The first is that S1 is copied into the temp buffer without checking the size to make sure it can fit within a 32-byte buffer. If the length of S1 is greater than 32 bytes, the copy operation could potentially lead to a buffer overflow. The second problem is that S2 is then concatenated into the temp buffer, and we're assuming that there's sufficient space left for S2 after the string copy of S1 has been performed. If the length of S1 is small enough, but the length of S1 plus S2 exceeds the maximum size of the temp buffer, again, a buffer overflow will occur. If you want to use STRSafe, all you need to do is to include the STRSafe header file, as is shown right there. Then you replace each band function with its appropriate STR string equivalent. Each of these functions, again, returns a status code the developer can use, and they can check the success or the failure of said function call. The STRSafe function takes a destination buffer size parameter, and it ensures that the function does not write past the end of the destination buffer and create a buffer overflow condition. As far as Safe CRT, the C runtime library included with the Microsoft Visual Studio 2005 and above has been enhanced to include more secure versions of common C runtime functions. This library, again, is known as Safe CRT, and you can go out to the link there if you want to see more. It provides a useful feature called secure template overloads. Whenever this thing right here, _CRT, _secure, _CPP, _overload, _standard, _names, when it's defined to 1, the compiler will automatically change banned function calls to use safer functions. So again, this provides a safer alternative and a more efficient way to enhance older apps. As far as an example of this, here's some sample code that allocates a 32-byte buffer called temp onto the stack and then copies S1 into temp. All right. Problem is the same one that we talked about earlier. If S1 is longer than 32 bytes, then the string copy of S1 into temp will result in the buffer overflow condition. Like STRSafe, developers can manually fix existing code to use safer functions where found. However, the Safe CRT library comes with that useful feature that if we set this thing right here, the CRT secure CPP overload standard names to 1, again, the compiler will automatically check for banned functions and then also automatically convert said banned functions into their safer versions. So which should you choose? Should you choose the STRSafe library, or should you use SafeCRT? The good news is, regardless of the one you choose, you're going to have a better code experience and less chance of buffer overflows than choosing neither one. So either of the libraries will be appropriate depending on the specific application engineering status. In some cases, you might not have a choice. Certain band functions may not have safer alternatives, but may have safer alternatives in another library. For example, a safer alternative function to the C library, runtime library ITOA, which is integer to ASCII, is available in SafeCRT, but it's not available in STRSafe. So, as we come to the end of this lesson, we again talked about Microsoft SDL band APIs. When you develop apps, at least in Microsoft's experience, certain functions within the C runtime library, when used incorrectly, can lead to serious vulnerabilities in code, such as buffer overflow conditions. Microsoft has therefore created the Software SDL band API list, which documents the set of known functions that can lead to vulnerabilities. It also provides safer function alternatives. Traditionally, again, developers have looked to the CN functions as a safer alternative, but due to their limitations and the fact that they can also be easily misused, Microsoft has banned those N functions also. Developers can detect instances of banned functions in their code through a variety of methods. We talked about the use of the Visual Studio 2005 and above compiler, which automatically alerts developers to the presence of banned functions. They can use the band.h header file, and they can include flag instances of banned functions during security code efforts. In other words, they can look for banned functions, all right, not just of other vulnerabilities in code. Finally, we talked about two of the safer alternatives, which were STRSafe and SafeCRT. Again, while these alternatives make it more difficult for developers to accidentally introduce vulnerabilities into code, they can still be used incorrectly. So again, we've now talked about secure design, secure implementation, secure verification, threat modeling tools, SQL injection, fuzz testing, cross-site scripting, buffer overflow, okay? And now we just talked about band APIs as well. Here's some additional resources, and I'll leave that up there for a second. Most of these were mentioned, of course, inside of the presentation that we just went over, but you can see them all in one place now. All right, so that's it for this presentation.